Okay. So today's topic is load balancer. Okay. Let me know if you're able to see the screen. Okay. So today's topic is load balancer. So before we get into the theory, okay, I would like to give you some kind of imagination. I mean, when somebody talks about load balancer, this picture should come to you. Okay. So load balancer means, as the name itself says, it will help. It is a device. Okay, it is a device. It is a device. It will help you to balance the load. What is the meaning of balancing the load? What is the meaning of balancing the load? Can somebody tell me what is balancing the load? Say for example,
Distributing
yeah, please go on.
distributing
Yeah, what is the balancing the load means?
distributing the load equally.
Correct. Distributing the loads equally.
Equally.
Yeah. Say for example, you have a computer here or a server here. So you have an application, okay. That application is hosted in the cloud. Maybe in the Western Europe region, this application is hosted. And since I have mentioned here in the cloud, this is a public cloud. So the
Manju,
application,
not able to see this.
you are unable to see the screen.
Yeah.
Is everyone?
Yeah, actually, you and I am unable to see the screen.
Okay, let me do. I have not shared only. Sorry. Can you see it now?
Yes.
Okay.
Yes.
See, I was just talking about what you mean by load balancer. Load balancer means you have told. Load balancer means it's a device. It will help you to balance the load among the backend nodes. Okay. So that is the abbreviation. So I also told you load balancer will not just balances the load, but it will also give you the high availability of the application. Means if you want your application to be available 99.9999 percentage of the time, you should use the solution called load balancing solution. Okay, Microsoft give you multiple options. Okay, you can have the load balancer, you can have the applications in the availability set, and you can also keep the applications in the availability zones. Okay, so many options they'll give you. Depend upon your budget and criticality of the application, you can solution accordingly. Okay, that is why when you are working as a solution architect, you should think all these things. First and foremost, what kind of application it is. Is it a production application? Yes, if it is a production application, how big impact it causes? Means the application mint the money like anything. Say for example, on a big billion day, if Amazon or Flipkart website goes down for half an hour, do you imagine how much business loss they have? The entire quarter business will go off there. Say for example, in the first 1 or 2 3 months, in the 3 months of time, if they do 10 lakhs of business, on the big billion day only they'll do 1 crore of business. Example I'm giving you. Imagine if the application is there down, I mean down for 1 hour, almost 20-30% of the business will go off. That is why what they will do while doing the solution, you have to consider all these factors. Okay, so coming to this picture, see, you have an application called facebook.com. Okay, so the Facebook is hosted in the cloud, Azure cloud or AWS cloud. In our case it is Azure cloud. And my customer have told me this will be my production application, and this will be accessed publicly. and he will tell I need high availability, and he also tells the application should perform very well. Application performance is important. So considering all these factors, what I have told, I have designed a solution. Okay, what is that solution? I have chosen cloud, like Microsoft Azure Cloud, and in the Western Europe, I have built an application server here. This is my server 1 and this is my server 2. So what I have done in the cloud, I have deployed a load balancer. This is the load balancer representation, guys. Okay, so I have deployed a load balancer, and I've given a front end IP to this one. This IP address is like 192.168.1.10. So whenever the users are trying to access an application, they will not directly access the application server, but they will access the application, the load balancer front end IP. This is my front end IP. Okay, so imagine, see here, when the users are not accessing the servers directly and they are trying to access the applications via the front end IP of the load balancer. So what happens, behind the load balancer, I have the backend pools created. This is called as backend pool. So this backend pool is there. Now, this backend pool can contain a number of machines. There is no limitations. Okay, there is limitations, like 100 and 1000 computers can be added, depends upon the load balancer's queue that you are using. Okay, so imagine if I have a load balancer and my application server, these are all the replica, means server 1 is the replica of the server 2, means whatever applications you have in the server 1, the same copy will be there in the application 2, the server 2 as well. So now, when say for example, there are around 1000 users are getting connected. Okay, this side 500, this side 500. Globally, I'm asking. This is the public load balancer, and globally user will access the application. So this load balancer is an intelligence device. Okay, it works on the principle called file tuple hashing algorithm. I'll explain you in the slide actually. Okay, what it will do, it will try to understand from which computer, from which and to which port the traffic is coming. So based on that, it will create an algorithm and it will try to send the query to the request to the respective servers. Okay, say for example here 500, here and 500. This load balancer, what it will do, it will try to send 500 requests to this server and 500 requests to this server. So it balances the load. Means there are 1000 users are trying to access the application called facebook.com. Okay, imagine if the load balancer is not intelligent enough, it may try to send all the requests to one server. Okay, if all the requests go to a single server, the server utilization will be spiked up and the computer and the application performance will be degraded. So considering that in the mind, we have designed the load balancer to detect the total amount of load it is coming, and it will distribute the load equally to the backend nodes accordingly. So if you have 1000 requests coming, if there is a 1000 requests are coming, what it will do, 500 will be sent to the server 1, another 500 will be sent to the server 2. And it is an intelligent device, I told you. Okay, what it will do, it will always try to probe the server. This I told you, the port number 80. So this load balancer will always try to query this server whether the server is responded back to the query of the port 80. So if the server is not responding to the query of the load balancer for the port number 80, it will consider this computer is not available, or maybe this server is shut down. What it will do, it will stop sending the query here, then all the 1000 users will be redirected here. This is what high availability means. There are two things when you are talking about the load balancer, you should understand. Load balancer will not just balances the load. It balances the load and it also increases the application performance and moreover it increases the availability of the application to an extent. See, Microsoft tells you if you want to have 6 digits of 6 digits of SLA, okay, which is 99.9999, 6 nines of SLA they'll call it as, okay. If you want 6 nines of SLA, you should plan the application behind the load balancer, and you can even put the application servers either in the availability set or availability zone. If you use both these options, the combination of availability set or availability zone and the load balancing, Microsoft will give you 99.9999% of the uptime. Means in a year only around 2 to 3 hours will be the downtime. If you have more than 2 to 3 hours of downtime, Microsoft will pay you back. You can penalize them. You can put the penalty on the Microsoft stating that you have breached the SLA. You need to pay me back because you have impacted the level of service whatever you have given. It is not up to the mark. You have impacted my business. So my business runs almost, it is down for 6 hours or 7 hours. And per hour my business loss will be this much. Please, not only about the business loss, it will also about the reputation. Imagine applications like Facebook or LinkedIn, Twitter, or Flipkart, Amazon goes down for a month. For a week. Not for a week, for 1 hour or 2 hours. Once in a year, their market share, the amount that will also comes down. Okay, everything is dependent upon the IT guys. That is why the solutioning, whatever you do, you have to keep all those things in your mind and you have to do the solutioning. Okay, so with this basic understanding, let me take you to the slide. Okay, hope you are able to see the screen. Any question before I go to the slide here? Are you guys able, did you got some idea on the load balancer?
Yes, sir.
Okay, so few more additional points about the load balancer. Okay, now you already have the basic understanding. The load balancer means, as I just told you, it's a device. Okay, what it will do, it will balances the load among the virtual machines which are behind the load balancer. If there is 2 servers and if the load balancer is getting 10 requests, it will distribute accordingly. Okay, with the help of this, what you can scale your application. Means your application performance will be good. Okay, and you can get high availability for your application. Means your the probability of losing the application is very, very less. Because in my previous example in the slide here, okay, I told you for some reason if the server when gets shut down or crashed also, the load balancer will try to redirect the load or the user from this server 1 to server 2 without letting you know. Means you will not even know whether my request has got redirected from server 1 to server 2. Means it is a seamless redirection. You don't even know. Hard swappable we will call it as, okay, like that. Okay, you will not know, but the applications will get redirected on another healthy node. Okay, that increases the availability of the application. And chances of losing your application is very, very minimal or negligible. Okay, if you have at least 2 to 3 backend nodes, you don't need to worry about the application downtime because at least one server will be up and running to give you the application. Okay, that is about the thing. So uses of load balancer. See, the load balancer is the load balancers to load balance the incoming internet traffic to your VMs. Okay, there are multiple types of load balancer. One is the public load balancer, another one is internal load balancer. If you are getting the request from a public internet, you need to have the public load balancer. If you are within the office, within your office premises, and you have some internal applications, maybe your HR portal or your HRMS, or maybe your leave application portal, or maybe your insurance, Mediassist, whatever, blah blah blah. Okay, if such kind of request comes, that is internal load balancer will be there. Means if the traffic is originating within your office network, then you need a load balancer called internal load balancer. If the traffic is coming from outside like public internet or public network, then you need a public load balancer. Okay, and to port forward traffic to a specific port on the specific VM, I told you na. So load balancer will detect what from which IP address the traffic is coming and to which port the traffic is going. So based on that, it creates a chart and it will understand, okay, to which virtual machine I need to send the query. Okay, and provide outbound connectivity for the VMs inside your VNet by using the public load balancer. Facilitates the outbound connectivity from a particular port from a virtual machine in the Azure VNet. Means, so it will provide the connectivity, okay, with the computer which is there within your virtual network. Okay, even though the virtual computer is within your virtual network, okay, you can even add a load balancer. I mean, behind the public load balancer, you can add your application server which is there in your local network or your virtual network. That is what it is telling. Once again, guys. Ma? Bye. Okay, so that is about the uses of load balancer. Okay, you see here the features of load balancer. See, load balancer works on the principle called, it is using a principle called 5-tuple hashing algorithm. You can see here in the interview they will ask you what kind of, how the load balancer, Azure load balancer works. You can tell Azure load balancer is a device, it will balances the load among the backend pool or backend nodes, and it also increases the application availability. And yeah, it works on a principle called 5-tuple hashing algorithm, okay, for to distribute the load among them. Okay, see here the load balancer is a 5-tuple hashing algorithm for load distribution of inbound flows, and rewrites the headers of flows backend pool instance accordingly. Means, say for example, if you have 3 virtual machines here, virtual machine 1, 2 and 3, okay, and if the requests are coming from the external world, okay, so what it will maintain, it will maintain 5 sources. What is this? The first one is, what is the source of the source IP address, from which computer or from which IP address I am getting the request. Then what is the source port? Means, if the traffic is coming from like in a PC01, it will maintain the PC01 IP address like 190. Look, I'll maintain here 192.168.1.10. It will also maintain the source port. What is the port number? Port number 80. And what is the destination IP address? Maybe it is public IP, no? 11.10.11.13. And what is the port? Maybe it is port number 443 HTTPS. Correct? And what is the protocol? Either it is TCP or UDP. So like this, it will maintain the table. Okay, that table is nothing but algorithm. So then it will know, okay, I'm getting the request from this one, okay, I'm sending here. So when the request from this IP address with this port and to this one, you send it to the virtual machine 1. So maybe next one coming like 192.168.1.11, same port, but here the IP address is getting changed, then the request will go to the VM2. Like this, it will maintain the hashing table. We will call it as hash table. Okay. See, source IP address, source port, destination IP address, destination port, and what is the protocol. Protocol means it is a TCP or UDP or whatever protocol you want to, the request comes. Okay. So with this slide, you got to know what is a load balancer and features of the load balancer and what are the uses of load balancer and how the load balancer works. The load balancer works on the principle called 5-tuple hashing algorithm. The 5-tuple is nothing but source IP address, source port number, destination IP address, destination port number, and the protocol. So this load balancer has got few things. One is front-end IP address. I was explaining you in my previous diagram. User will never use an IP address of a server to access an application. What they will do? They will try to access an application using the front-end IP address of the load balancer, because front-end IP address is always a static one. Correct, na? No matter what, this front-end load balancer IP should be common. If you want to add n number of backend pool, it depends on. Okay, normal days maybe the Facebook or the Flipkart or Amazon would have been only, I mean, it would have only two computers. But during the big billion day or during the end of year sales, what they will do, they will increase the number of virtual machine. By why? Because the traffic on that day towards the application is high. Keeping that in the mind, what they will do, they will add additional server in the backend node. You can add n number of n number. There is no limitations. I mean, there is a limitation for the basic queue of the load balancer. You will have only 100 nodes can be added. For the standard one, you can add up to 1000 nodes. Okay, but who will add 1000 servers in the entire company itself? We will have around 1000 to 2000 servers. Okay, so now you know that. And in the backend pool is nothing but, okay, the backend pool is nothing but, okay, let me write here. Okay, so say for example here, this is your front end IP address. I think next slide I have it. See here, this is your, see, this is the public load balancer, and this public load balancer has got an IP address. What is that IP address? 192.168.110.10.10. Okay, so here behind this you have a pool. This is called as pool, backend pool. So this backend pool will have at least one server or maximum 1000 servers if it is a standard. If it is a basic SKU, then 100 servers. SKU means what is SKU? What is SKU, guys? Stock keeping unit. Means this is one of the tariff. Like you when you buy the phone, when you recharge, you may recharge like I just need 1 GB per day. Then another your friend tell, no, I also use sometime I also do office work. I cannot survive with 1 GB. I need 2 GB. He'll go with 400 rupees per month package. So SKU is nothing but the tariff. So SKU means it is stock keeping unit. Stock keeping unit is nothing but it is a tariff. Maybe in the basic SKU, the load balancer will support only HTTP and HTTPS, not others. Okay, or maybe 100 SKUs or 100 computer can be added in the backend pool. In the standard one, you can go up to 1000 computers. So there are some differences. I'll explain you. Okay, so basically, the computer will have the front end IP address, backend pools. Okay, and also we will have probes, health probe. Another one is health probe. So this load balancer, what it will do, it will tell you, try to check whether this VM is sending responses for your port number 80, the HTTP query. If the probing means always try to check the health of this VM, that is called as probing. The load balancer, every 5 seconds, it will try to talk to the virtual machine whether the virtual machine is responding back or not. If the virtual machine is not responding, the load balancer will consider the virtual machine is unhealthy and it will just leave it from the distribution. That is called as health probe. Another one is load balancing rules. Another one is LB rules. Okay, LB rules means using which port or what kind of protocol you need to send the queries. Okay, here you see you need to use port number 80. Okay, port number 80 means it's HTTP protocol, hypertext transport protocol, and you need to access application. This is called as load balancing rules. Okay, to make you more understanding, you see here. Okay, I will show you anyway. Maybe today it is not possible. Tomorrow I'll show you while creating the load balancer. Okay. So this is how the load balancer, the feature of load balancer, and this is how the load balancer works. It works on the 5-tuple hashing algorithm. Now you know. Okay. and you also understood what is a front-end IP, what is a back-end pool, and load balancing rules and health prob. Front-end IP is nothing but each and every load balancer, whether it is a public load balancer or a private load balancer or internal load balancer, it will have an IP address. The users will always use the IP address of the load balancer to access application, but behind the load balancer we have the backend pool added. We will create a backend pool, and inside the backend pool we will add the servers like server 1, server 2, server 3. Okay, and then create the load balancing rules. What kind of rules, I mean, how the application should open, whether the application should open for HTTP or HTTPS, or what kind of ports you wanted to enable, you need to create in the load balancing rule. Once the load balancing rule is created, then you will set the load balancer to have the redundancy. Okay, how a load balancer will understand for some reason any of the virtual machine is down, or say for example you are doing patching activity, you shut down the virtual machine 3. If the load balancer is unable to detect that virtual machine 3 is down, if it is sending the query to the virtual machine 3, then the application will fail you. User will not be able to access the application. To keep that in mind and to come out of such kind of issues, we have created a concept called health prob. Means load balancer will try to probe each and every virtual machines once in 5 seconds. It will just say hi, and the computer should say back hi. Once the handshake is done, once the validation, the probing is done, the load balancer will consider that as a healthy. If the virtual machine is not responding to the queries of the probes of the load balancer, then the LB will consider the virtual machine is down, and then it will try to switch or redirect the workloads to the remaining healthy nodes like virtual machine 1 and virtual machine 2. Okay, and with this there are two different SKUs of load balancer. Okay, one is the basic SKU. We will call it as SKU is nothing but a stack keeping unit. Okay, another one is standard SKU. The basic and standard SKU, there are two SKUs of virtual machines. Okay, and the feature will be varied, the differences. Okay, and you see in the standard SKU, I just told you, you can go up to 1000 instances in the backend node. See, 1000 computers in the standard, 100 instances in the basic. Like you have only 100 GB per day, here you have 1000 GB per day. Price difference will be there. Okay, and in the backend pool endpoint, you can put any VMs in the single VNet or multiple VNet or availability set and virtual machine scale set. Means if the in the backend pool, here in the basic SKU, you can only keep the virtual machine within a single availability set or virtual machine scale set. I mean, standalone servers can be added behind the load balancer, or the VMs from a same VNet can be put, availability set can be put here. But here you see, you can put from wherever you want. Any VMs in the single VNet, or VMs from multiple VNet, or multiple availability set, also the VM scale set. There is no limitations. You can put the virtual machine from a different region also, different VNet also, different resource group also, and different availability set also. Means you see a VM wherever you want within the same subscription can be added here. There is no things, I mean hardened rules that you should not keep on the. Okay, that is called as the backend pool endpoint difference. The standard SKU will always be better. Standard SKU will be always be better because the price will be slightly different. When you are solutioning, okay, you need to consider whether it is a public load balancer or a private load balancer you needed. Okay, so the SKU can be always considered as the standard SKU. Okay, because you cannot convert basic to standard directly. You need to do a lot of changes. You need to do some scriptings and all. Okay, you need to create a load balancer, and then you need to write some script to create the backend pool, health prob, load balancing rules, and move the virtual machine from the old load balancer to the new load balancer. It requires some amount of time. Okay, that's why. And then health prob, you see here in the standard, I told you only in the basic I told you only TCP and HTTP, if you remember. But in the help standard one, we see you can put TCP, HTTP and HTTPS. All the traffics you can put in the standards queue. But in the health probe down behavior, whenever the health probe goes down, okay, TCP connections stay alive on the instance when the probe down and all the probes down. Means the TCP connection will always be established. It will just wait. Maybe say for example, you have 3 servers and all the 3 servers goes down. The load balancer in the basics queue, it will also just ignore everything. It will not check, oh, all the computer went down, I don't have any work, let me relax, like that in the basics queue. But in the standards queue, even though you have all the 3 computers goes down, but the TCP connection will wait. Maybe now maybe after 2 minutes the server is coming up. It will try to check always whether the computer is coming up or not. Like it will try to keep an eye. It will keep on monitoring, and as soon as the computer comes up, it starts sending the query. But in case of basic, it is not like that. You need to manually start. That is the difference. Okay, and availability zone. You see here, you can keep the virtual machine from the different availability zones also, zone 1, zone 2, zone 3. Okay, but in the basic, you cannot keep. The virtual machine should be within the same availability zone, or it is zoneless. If there is no redundancy, means then only you can put it. But the redundant VMs cannot be put in the basic one, but here redundant VMs can be put it in the standards queue behind the load balancer pool. Okay, and management operations, see, most operation takes less than 30 seconds. The performance means you do some changes, like you are creating a load balancer rule or you are doing some modification. That modification takes effect within less than 30 seconds here. Not even 30 seconds, that is max. Less than 30 seconds I am telling. Now I am not telling 30 seconds, I am saying it happens within less than 30 seconds. But here you see, typically it needs minimum 1 minute, 60 seconds, and maximum 90 seconds. Okay, so the performance is pretty much faster compared to the basic in the standard one. And the pricing, you see, if you go to the basic load balancer, it is a free of cost. No much, it is there is no cost at all for the free SKU of load balancer. But for the standard one, the charging is depend upon the egress and ingress, or the data process egress and ingress. Means egress and ingress means, say for example, let me go here. So here you are trying to access some, you are sitting here and you are trying to access some application, and the application is coming here, correct now? So this is called as ingress. It is incoming traffic to the cloud, that is called as ingress. And when you are reading something from the load balancer back to the computer, that is called as egress. Ingress means the traffic going inside the cloud. Egress means the traffic coming outside of the cloud. Okay, so say for example, you are writing some 100 MB of data or 1 GB of data. Okay, and you are just copying or reading maybe 1 GB of data. So here the charge is only for the 2 GB transaction data. There is no hard or fixed price for the load balancer. The charge of the load balancer will be depend upon the amount of data get transacted. Okay, and the transaction we will call it as egress and ingress. Okay, so just a quick recall about the load balancer. Finally, the load balancer means it is a device in the cloud. It balances the load among the virtual machines behind the backend pool. So the load balancer will help you to increase the application performance. It will also increase the application availability, and the probability of losing the application is very less. So with this option, Microsoft will give you 99.99% of the availability. And there are two types of load balancer: public load balancer and the internal load balancer. Okay, you can use public load balancer for the public traffic, and for the internal one you can use the internal traffic. And the load balancer works on a principle called 5-tuple hash algorithm. So it will always consider 5 points. That is why it is 5-tuple, we'll call it as. The 5 tuples are like source IP, source port, destination IP, destination port, and the protocols. So these are the 5 tuples which the load balancer considers to send the query from the originating place to the load balancer. Okay. So when we talk about the load balancer, we should also understand couple of parameters or the components. One is the front end IP address, another one is the backend pool, third one is the load balancing rule, and the health probe. Front end IP is nothing but each and every load balancer will have an IP address, and that IP address will be static. Once you create a load balancer, you will have an IP address. Till you destroy the load balancer, you will have the same IP address. So no matter what, the user will always try to hit the load balancer, and load balancer will balances the load among the application servers behind the LB load balancer. That is called as front end IP. And within behind this front end IP address, we have an option called backend pool. Within that backend pool, you can keep the application servers depend upon your requirement. Minimum one server should be there, minimum. But if you keep one server, it won't get balanced. It is a like single point of failure. So Microsoft recommend you to keep at least 2 to 3, and maximum you can keep 100 in the basics queue, 1000 in the standards queue. And then we are also creating the rules called load balancing rules. We will tell the load balancer how the traffic should be accessed via this one. Like whether you want to use a TCP connection or UDP connection, or you want to use a HTTP or HTTPS connection. You can just define in the load balancer rule. If there is no load balancing rule, you will not be able to access the application because computer will not understand. Because it says source IP, source port, and destination IP, destination port. So in the load balancer rule only you are mentioning which port of traffic it should go, like that. And then the protocol. Protocol is obviously TCP or UDP. You can mention the protocol. And the last one is the health probe. Health probe is very, very important to check whether the health status of the virtual machines which are behind the load balancer are healthy or not. The load balancer will always try to probe the computers behind the load balancer to verify the status of their health. Every 5 seconds it will just say hi message, and it will just, once it get the response back, it will consider the load balancer is healthy. If there is no response comes, it will mark it as unhealthy and switch or redirect the traffic to other virtual machines, the healthy virtual machines behind the load balancer. That is the thing. And understand you did, there are two different SKUs. SKU means stock keeping unit actually, and basic and standard SKUs are there. And you know the differences. Basic only supports 100 instances, standard supports 1000 instances, and basic support, it's a single availability set VM and the standalone VMs, but the standard supports availability, different availability set, different scale set, different VNets, different RGs. Health probe will be supported by TCP, HTTP, HTTPS in the standard, but in the basic only TCP and HTTP, no HTTPS. And availability zone, it supports the standard one, but basic doesn't support. Okay, operations pretty much faster in the standard queue, but in the basic it takes time like 60 to 90 seconds. Pricing, the basic one is it is completely free, but the standard queue, the pricing depends upon the egress and ingress. And this is just the load balancing visualization, how a load balancer looks like. You see here, this is how a load balancer looks like. Okay, this is the public load balancer, and this is web tier, and you see this is the backend pool, and we have 3 virtual machines, and we have created the Azure balancer load balancer roles like HTTP. Okay, and this is a virtual network. And how to build a virtual machine? You see, this is the lab. Steps to build the load balancer. Just take a photo of it. Try to build the same things. Tomorrow we will just check. Okay. What you have to do, you have to log into the Azure portal, create two virtual machines. Maybe you can put in the same VNet or in two different VNet, not a problem. And create a load balancer, public or private, no matter, but I would request you to create a public one because we can check now. And create a backend pool and add the backend nodes VM1 and VM2, add it, and then go to the probs and create both HTTP and HTTPS probs there and create the load balancing rules. Once you create this one, log into the VMs, the both VM1 and VM2, install the Internet Information Service, the IIS, the web tier on, okay, and then try to browse the front end IP of the load balancer, and the request will go and hit different virtual machine when both are up and running, and shut down a computer and see every time you try it will go to the only the healthy node. Okay, that is how you need to do the lab. With that, I think we are done with the load balancer theory. Tomorrow we will try to do the practicals. Okay, so let me stop the recording and then I'll take the questions.